You're listening to Climate Champions, a podcast from the Architects Journal. I'm Hattie Hartman, Sustainability Editor at the Architects Journal.
And I'm Hattie's co-host, Joe Jack Williams, a partner at Fielding Clegg Bradley Studios.
We've been developing building materials at a time of kind of abundant energy and resources. As we look towards the fact that we're very aware of our finite resources, we've got an abundance of waste. I really think we need to be adapting our architecture to be able to accommodate those sorts of materials. In doing so, I think it opens the doors to being able to be more innovative with the materials and potentially using less environmentally onerous materials.
Our guest today is Sean Ricketts, Sustainability Lead at 40 Strong Practice Carmody Gwork Architects. Last year, Fast Company named Carmody Gwork one of architecture's 10 most innovative companies for developing a replicable way of making bricks out of municipal waste. The prototype brick is now being manufactured for the Design Museum project in Ghent, Belgium, for which Sean is project architect. The waste is sourced from within 7 kilometers of the project, and the new bricks are made on a brownfield site on the city's outskirts. Carmody Gwork is also working with Imperial College-based startup Ceratec to develop a brick that uses a magnesium binder and can be baked at 60 degrees rather than fired at 1200 degrees like most conventional bricks. Sean, you trained as an architect at Cambridge, but much of your recent work is focused on materiality, and you are currently sustainability lead at Carmody Gwork. Tell us a little bit about your journey and how you took on a lead sustainability role at the practice.
Hi. Yes, so I did my postgrad at Cambridge from 2015 through to 2017. I did my undergraduate at London Met. And I suppose sustainability is something that's always kind of been a driver. I come from a background in fine art sculpture. So from there was always an interest in sort of land art, ecology, landscape, the kind of intersection between buildings and, say, landscape settings. And I think materiality and sustainability is a really key part of that. And then I've been more recently involved in Architects Declare, in ACAN, and have been kind of pushing, I guess, within practice. At Carmody Gwork, we've developed this new role, and it's really about empowering other members of the practice to kind of be probing and asking the right questions, sort of shifting mindsets, I suppose, not seeing sustainability or sustainable design as a kind of nice to have or an optional add-on, but having it as a kind of metric which is intrinsic to what we consider good architecture.
Great to hear, Sean. You're coming from a bit of a blended background, the hands-on role of sculpture and fine arts. Do you think that's something that's really supported you as you've gone forward as an architect?
I think so, yeah. I sort of mentioned materiality. I think that's a really key thing. And some of my interests in architecture are really on kind of the stuff and substance that things are made out of and the richness of materials and objects.
I think that interest in materiality really comes through in your Ghent project. I just wondered, how did you start looking at the new brick for Ghent? And what was the kind of catalyst for rethinking bricks in the first place?
I mean, from the outset, it felt very appropriate for this to be a brick building within the context of Flanders. So Ghent is the capital of Flanders in northern Belgium. I guess what we know about conventional clay-fired bricks is that they have a very high embodied carbon. So we started sort of seeking alternatives. We didn't necessarily set out to develop a bespoke brick, but we also recognized that the facade of this design museum really needed to be special. It needed to be crafted, and that was potentially bespoke. So we began very early conversations with Local Work Studio way back in sort of 2020 around alternatives to clay-fired bricks. And Ben, one of the co-directors of Local Work Studio, he's an absolute wealth of knowledge when it comes to everything around sort of remaking and repurposing. And they've been developing these sort of compressed bricks for a really long time with various different waste aggregates and binders. He highlighted to us that there was this opportunity to use alternative binders, and in this case lime, which cures rather than being fired in an oven. And that was really the kind of inception. It was those conversations with Local Works Studio that took us down this route. I think it's also worth mentioning that we had a sort of fantastic joint client on this project. So the Design Museum and also SoGent, they were able to secure 100,000 euros in funding from Circular Flanders to carry out the very early stages of this research.
That's exactly what I was going to ask, was how did you find the time and funding to do this?
The funding came from Circular Flanders, really, that very early funding. And the time's a good question. This was all happening during COVID, and
time was elastic.
There was lots of time to sort of sit around and not sit around, but, think about stuff and have conversations that you might not necessarily have the kind of headspace or capacity to get to in, let's say, more kind of conventional times.
I mean, it's interesting because you talk about lime as a binder, and I think perhaps it's underutilized. How did you start to think about what's around, what's available? What is that process? Is it a replicable thing that others could take up?
Your point on lime is a kind of undervalued and underloved material. Like I absolutely agree. There are lots of people I can put you in touch with who wax lyrical about how fantastic lime is, not only in the kind of conservation context that we're more familiar with, but for instance, such as we're doing, where we're making a compressed block, but also lime plasters, lime renders, lime floor. It's a really versatile and much more environmentally friendly material than polymer and cementitious base binders. But I guess it's key to kind of note that lime comes from the firing of limestone, so it's not a kind of zero energy process. It does have an embodied carbon associated with it, albeit it's much lower. Lime sort of exists on a spectrum with what we call feeble lime at one end and cementitious clinker at the other end. And the further you move up that spectrum, the more energy intensive the actual process of producing the binder is. So the lime we're using sort of sits at the, let's say, the feeble lime of the spectrum. So it doesn't have such a high embodied carbon as other binders. In terms of available waste streams and how we identified those, so again, this is a lot of credit to Local Works Studio, who, as I said, they've been working on these themes for a really long time. So they identified things that we could use as a substitute to your, I guess, conventional virgin silicates. So in typical clay-fired bricks, you have clay, which is your binder, and then you have a silicate, and that will typically be virgin sand. We know there's lots of problems with the extraction and mining of virgin sand. It's causing kind of havoc to watercourses globally. So if we can identify something that we can use that has the same kind of properties and access and is indeed a silicate, then we could substitute. So we started looking initially at excavation waste. We kind of had this mad moment where we were asking our partner architects, Atema, to send us boxes. Again, this is COVID, we couldn't go over there, but kind of send us big plastic boxes with actual excavation waste from the city of Gentin. So we could start to make these very early prototypes that took excavation waste, so kind of clays and mud from the city, and sent them over here. So Ben made the early prototypes with that. And then it was really conversations with the client that moved us away from kind of using an excavation waste to using more industrial waste. So glass, industrial glass, both from windows, car windscreens, that sort of thing. We even trialed bricks that were made out of beer bottles, so kind of browns and greens. Interestingly, the lime didn't bind very well with the beer bottles, primarily because there was a kind of residual glucose from the beer in those with those silicates. So that was a kind of fun trajectory to go down, and then be like, oh no, that's a shame.
So converting all this research and prototypes into an actual project sounds challenging. What were some of the barriers you faced, and how did you overcome them?
Yeah, there's another key party who are involved in this process, which is of course BC Materials.
Describe them, because I don't think all our listeners know who they are.
So BC Materials, they're based in Brussels. They're BC Materials and Architects. So they've got their sort of material research side and also their architecture side of their practice. They come from a background in kind of earth construction. They're super fantastic, really innovative, really kind of open, collaborative practice. And we basically told them about the work that we've been doing with Ben. We really recognized that this research needed to kind of continue within a European Belgium setting in order for it to kind of stand any chance of manifesting into a building material that could be used on the project. So they sort of took on the role of R&D and are now going to be actually producing the bricks for us. In fact, the bricks are being produced at the moment. We went to the fabrication site a couple of weeks ago and saw the kind of the production line of the bricks developing. But yeah, in terms of kind of certification and testing, we sort of went through this initial phase of initial testing for things like compressive strength and appearance. And then we took on later rounds of testing where we looked at things like gross dry density, freeze thaw, water absorption, even to the point that you're testing carbonation to see how well the lime has cured as the block sort of dries. There's no designated standards or Eurocodes for this sort of brick. It's most similar chemically to a calcium silicate block. However, the key difference is that it hasn't undergone the autoclaving process and uses reclaimed silicates rather than virgin sand. So for that reason, together with BC Materials and the client, we had to engage BCCA, who are kind of governing body who provide services for kind of technical approval. With them, we were able to develop a bespoke schedule of tests, which would demonstrate compliance across various metrics and demonstrate that the brick was fit for purpose for a sort of given application. They also provide things like installation advice and detailing advice.
Yeah, it sounds fantastic. There's a phenomenal amount of work in getting a product as simple as a brick to be actually used. What's the kind of programming implications for this? Because obviously you could pick a brick off a standard product and it'd be away you'd go. But this, the fantastic nature of this is it's been built and it's actually happening. So how do you broach that with a client?
As I said, we didn't set out to do this in the way that it's happened. So we didn't necessarily program in all of this testing and all of these kind of iterations to recipes and things like that. So it has had some program implications. But I suppose people have really sort of bought into the idea of it. There's a very beautiful narrative around building a new museum for the city of Ghent with waste from the city of Ghent. It kind of epitomizes circularity and all of the kind of really rich, current and important topics that we need to be engaging in, and indeed which the Design Museum in Ghent really embrace. So it was almost like by the time the program implications became very apparent, and I'm sort of talking 4 or 5 months, not huge years of time, but it was like there was so much investment in it that it really needed to kind of go ahead despite the knock-on implications.
And so many people talk about, having a good narrative to explain what you're trying to do. And it sounds almost superficial, but it is also key to being able to take something forward. And you need a client who has the vision for it. But once you get to a certain point, it has a life of its own.
Absolutely. And what we've seen, I mean, it's pretty amazing. So in a couple of weeks, we're going to be going over to Ghent, and they're having a whole festival of brick making to celebrate circularity, to celebrate the start of this production. And it's, so it goes beyond a festival of kind of making bricks. There's talks, there's lectures. I've heard rumors of a scrub of waste-based aggregate and a sauna made out of who knows what, maybe bricks. And that's all been led by the client. That's all the client's initiative. And it feeds into a really fantastic fundraising program and publications and publicity around the project. So it's, as you say, it's absolutely taken on a life of its own, which is fantastic.
I want to ask you a little bit about the embodied carbon of your new brick. In a recent episode, we spoke to Martha Lewis of Henning Larsen, and she has developed this very useful unboxing carbon catalog. And the bricks she has, maybe 20 types of bricks on there that she's developed through workshops. And the bricks range from 0.52 kilograms of embodied carbon for reused bricks to over 60 for certain Danish bricks that have been fired a certain number of times. So you've said that the Ghent brick has approximately 1/3 the embodied carbon of a typical Belgian clay brick, measured over a 60-year life. Do you have a carbon footprint for your brick?
We tested the embodied carbon of the brick over a 60-year life cycle, stages A to D. We found that the Belgium clay brick data is sourced from Totem, and we've got it at 0.17 kilograms CO2e compared to a Belgium clay brick, which is 0.54 over a 60-year life cycle.
Well, I think there's a really interesting point here about, does everything need an EPD to know it's a lower carbon product? When we talk to some of the natural building specialists, they have materials that are from the site and are done using kind of hand methods and hand tools, and they're kind of inherently low carbon, but they don't have the number. So it's a question, are you going to go down the route of getting an EPD? And, do you have a rough idea? And actually, is a rough idea enough, I suppose?
Yeah, you raise a really good point, Joe, in that it's easy to get really, really hung up on this stuff, but we do know instinctively, we know that the embodied carbon associated with the production of lime is much less than, say, if it were to be a clay-fired brick. And also it's made out of 60% waste, all within a relatively small radius of a city of Ghent. So you don't have any of those carbon associated with the transportation. We also know that 60% of the brick is waste material. So there's none of that extraction process that we've kind of already talked about. There's none of the global extraction of, say, sand that we've discussed. And also it's all being produced within a very small radius of the city of Ghent. So there's none of the associated carbon with transportation and movement of materials. So I think all of that combined is very favourable.
Excellent. I mean, it is really interesting. Some of these things are so intuitive, they kind of make sense without having to do the numbers and the kind of hard crunching. I think that's a really important point.
Yeah, absolutely. I mean, it's about developing an intuition and rules of thumb. And I guess it's also about not being necessarily scared of getting it wrong. I think as an industry, we're all going through a huge learning process, and the marginal gains that we can make are very good at it. Even if it's just a little bit, it's better than nothing.
Well, that's it. I think on every project, trying to find where you can make that difference. And here, I think you're making a huge difference, just in terms of setting a precedent for how one can go about this. So one question I have is, could this be done in the UK? Something like this?
Potentially. So the certification process that I described earlier is applicable to the UK. This product can't be used in the UK. It's only certified for its specific use, but there's nothing to suggest that you can't kind of replicate that process. And it's the process that's described very well in David Watson's chapter in Materials and Environmental Primer, which is where you go through, I guess it's an exemption route using either European technical assessment or technical approval. And it's that process of being able to demonstrate kind of fit for purpose for a particular application. BC Materials have also produced, alongside the production of the bricks, they're also producing a bespoke mortar for use on the project. The two really sit together as a sort of whole facade system, which is really nice. And the mortar also has waste aggregates in it, and it kind of sparkles, and that's really beautiful.
What is the circular economy future for this type of brick? Can they be reused or turned back into their original component parts?
Essentially you could crush it and reuse it for something else.
So the Ghent brick is very white. Was that an aesthetic decision, or is that a result of the components that you're using?
It was an aesthetic decision and has therefore driven the components that we're using. We got this project through a competition, and even those very early renders for the competition were showing a white building. That's always been a kind of key characteristic of the project. What we found throughout the city of Ghent is that let's say the most important sort of civic buildings throughout the city tend to be white. And I think we felt it was appropriate for this museum to kind of sit within the context of those other civic buildings.
I think there's something really nice about the fact you still have an awful lot of design freedom to pick the color of a brick, but you still have a waste stream that's being absorbed and reused. I think that's lovely.
It adds some complexity. If you imagine when you're using kind of a crushed aggregate, the smaller the particles, the more they're likely to act as sort of pigmentation. So lots and lots of tests were done in order to kind of refine the mix and refine the size of the aggregates into such a way that they wouldn't sort of pigment the brick too much and move away from the kind of very beautiful bright white, which is what the lime naturally is.
So, do you think we're at a kind of turning point in architecture where a different aesthetic is now necessary, sort of a reconnection with regional vernacular and local supply chains that are expressed in the way a building looks?
I mean, I hope very much we are. I think that's absolutely what's necessary. I think as we've gone through this process, we've reflected on the fact that we've been developing building materials at a time of kind of abundant energy and resources in one way. We haven't been thinking about whether or not they are almost over exceeding their applicable use in so much as we're making these kind of very hard, very robust materials and applying that in every application, which is obviously to kind of de-risk things. But as we look towards the fact that we're very aware of our finite resources, the resources that are running out, we've got an abundance of waste. I really think we need to be adapting our architecture to be able to accommodate those sorts of materials. And some of that comes through the detailing, some of that comes through, well, primarily it comes through the detailing, but also I think maintenance is key. We've been trying to develop building materials that don't need to be maintained. Well, we don't question the maintenance of, say, very, very special historic buildings, your grade 1 listed castle or whatever. It's understood that maintenance is part and parcel of looking after those sorts of buildings. We need to move away from the idea that you can build a building and it's completely static, and we don't need to be thinking about sort of looking after it. And in doing so, I think it opens the doors to being able to be more innovative with the materials and potentially using less environmentally onerous materials.
So is this project having a knock-on effect on other work in the practice currently?
I think so. I think the origins of the practice, it was set up in the recession back in 2008, and the sort of ethos was all about finding opportunities to do the most with the least. So some of our kind of early projects, the filling station, for example, there's the kind of creative adaptation of an existing structure to kind of make them more culturally relevant and engage with local neighborhoods. But I think that kind of attitude towards innovation and fun, and as I say, the most of the least, has always been a strand. But I think certainly circularity as a kind of topic is a far more prominent theme in the office. And I think the project in Ghent has kind of really strengthened our confidence in seeking out opportunities. And also, I guess, working with really, really good people, working with people like Local Work Studio. Not only have they helped us with this brick, but they've also done a whole host of demolition audits on some of our projects, and really understanding what the opportunities for kind of reuse and circularity are has become increasingly discussed.
What about the work that you're doing with Ceratec on these bricks that use a magnesium brine? Are you involved with that project?
Yeah, absolutely. Yeah. So we were lucky enough to receive some funding from the Future Observatory, which is based at the Design Museum in London. And that was some research and development funding. And we partnered with Ceratec. We were talking about the Ghent brick, and we said, is the scope to do this with the binder that they're producing, which is MagCarb? So we've gone through that process with them as well, and been testing different aggregates and testing what happens when you start to introduce things like, I mean, Hattie, I know you came to our seaweed sessions, and that was because we were looking at whether or not you could reduce the freeze thaw on a brick by introducing a natural polymer to inhibit expansion and contraction of the brick, which helps in terms of the facade engineering and the detailing.
Mm-hmm. So the seaweed would act as a kind of mesh to kind of knit it together.
You see it a lot in sort of traditional Japanese plastering, for example. It's not seaweed as the sort of leaves, as it were. It's like it gets cooked into glue, and the glue is this kind of gloopy, quite viscous substance that then gets added to the mix of the bricks with the intention that it prevents it from taking on too much moisture.
I love the fact you're able to talk about how textural it is. You know, this isn't a product in the catalogue. It's a gloopy stuff that you mix in. I think that's really special.
Thank you very much, Sean. That was a really great explanation of what you've been through and what you're living live at the moment on this Ghent project. It's fantastic to see this kind of exploration actually taking shape in a building.
Thank you so much. It's been a really lovely chat.
Our next guest will be South Indian architect Vinu Daniel, who builds poetic buildings incorporating waste. You can find the show notes for this episode at www.architectsjournal.co.uk/podcasts, where you can also catch up with all our previous episodes. If you're enjoying Climate Champions, please subscribe and do rate us on your favorite podcast platform. It helps people find us. Thanks.